A very good day to Dr. Wong Wiki and our invited guests, as well as our fellow friends. Today we'll be pitching a product developed in this semester. So in Malaysia, the population above the age of 65 years old comprise about 7.4% of the total population in the year 2031. About 37.27% of elderly reported falls in the past 1 year. Falls can cause many severe complications such as fractures, injury, hospitalization, and even deaths. In worldwide, it's estimated that falls result in 424,000 deaths every year. So these are the main factors of falls in elderly: muscle weakness, increasing age, medication use, cognitive impairment, cardiovascular diseases, and sensory deficits. So for the design of our device, we will be using M560 Plus and a pulse sensor. At first, we designed a user-friendly menu, which incorporates a simple GUI design and a two-way navigation board-based menu. So the user have to press button A to select the next mode and button B to select the previous mode. In this slide, we will cover the list of modes and features implemented in this M560 Plus watch. So the first mode is the date and time display, which it will display the date and the time as well as the day of the week. In this mode, you also have an idle mode that will turn off the LCD after 10 seconds of inactivity. This mode is also known as the power saving mode. So for mode 2, we'll have a heartbeat monitor, which it measures the heartbeat of the user upon entering the mode. This mode uses the most power because of the connected pulse sensor, which will draw current from the battery. So for the third mode, we have a medical reminder. In this mode, the M560 Plus will initiate communication pathway between the Telegram bot for setting up the medical reminder.
The MPU Z886 in the M5 watch is used to obtain the triaxial acceleration magnitude and triaxial angular velocity value. The fall detection is a threshold-based algorithm based on three thresholds: lower fall threshold LFT, upper fall threshold UFT, and angular velocity threshold. The first two thresholds are based on the acceleration magnitude. The first threshold is to determine if the user is wearing the watch, while the second threshold is used to determine if the user accelerates faster than their daily activities. The last threshold is used to determine if the watch rotates about an axis, for example, if the user is rolling down the stairs. The algorithm also determines the fall detection based on the orientation change after the third trigger has been triggered. After a fall has been detected, a Telegram message will be sent to a Telegram user via a bot. In our fall detection system, three fall scenarios are considered. The first one is when the user regains movement after a fall has been detected. Hence, a warning message will not be sent. However, if the user wishes to send a warning message, the user can press the side button for 3 seconds to send the message. The second scenario is when the user presses the main button to cancel the warning message when a fall has been detected. The third scenario is when the user remains unconscious for a few seconds, hence a warning message will be sent. In order to determine LFT and UFT, the acceleration magnitude for activities of daily life, or in short ADL, are displayed in this table. As you can see here, the highest upper peak value, which is running 2G, and lowest lower peak value 0.4G, which are lying down and walking downstairs, are set as a reference to determine the UFT and LFT. The specificity in all ADL have 100% accuracy, which means that no false alarm during ADL are triggered. Hence, the lower fall threshold and upper fall threshold are set as 2G and 6G respectively, while the angular velocity threshold is set between 300 and 2000 radian per second. The falls simulated are considered as heavy fall. From the fall experiment, the acceleration magnitude during fall greatly exceeds the UFT with values of 10G and 13G. The UFT is set lower in order to detect light falls. Hence, here are the experimental results of successful and failed falls from the fall detection. Forward fall with the highest accuracy is the easiest and most common fall out of the fall types. The backward fall has the lowest accuracy due to complexity in mimicking the fall. In summary, the total of 84 falls performed has a 85.7% success rate.
Now I will discuss about the BPM calculation of this medical watch. BPM is a measurement of human heartbeat per minute. An easy method to measure BPM is by laying a finger on your wrist or on the neck to count the total beats in 1 minute. For our project, we used the combination of M5 Stick C+ watch and an external pulse sensor to calculate BPM of the user. By placing the pulse onto the skin close to blood veins such as fingertip or wrist, it can detect the change in pressure as the blood pumps through and input data into watch. This diagram shows the analog data obtained with pulse sensor on the fingertip. As blood pumps, the difference in volume flowing through vessel result in high peak input value. Considering the first peak of input is the start of a beat and the next is another, interval between two peaks is counted as a period of one full beat cycle in unit of millisecond. BPM can be calculated with the frequency formula such that the BPM is one of period multiplied by 60,000, converting from millisecond to minute. In order to find the instant or time for each peak value, we first declare a variable name called higher value start with 0, where present input with higher reading will be assigned into this variable. At the same time, Billy's function keeps the update of the time or instant every time it encounters a higher value. This value remains when the reading drops from the peak, since condition is not met. After that, we predefine a threshold value, for example 400. If the watch detected a threshold value between the higher value and current reading, it indicates the end of this cycle and will start with another cycle. With similar method, we can obtain the instant of next peak for our BPM calculation. However, this version of BPM calculator shows low precision when applying in different scenarios. This diagram shows different pictures of pulse sensor input from different users. We observe that the threshold is varying from 300 to 2000, causing the measurement of BPM using prefix threshold to be inaccurate. For example, if we are using a threshold of 500 in this scenario, multiple peak instants will be recognized in a cycle instead of one. To solve this problem, we find the lowest peak value with the same method, finding the high peak value, and set half of the peak to peak magnitude as the threshold value. We tested both of the methods. The first one, with a predefined threshold, can achieve a reasonable heartbeat with a correct threshold, but is outperformed by the second model in terms of precision and accuracy. The value showing here is the calculated BPM after encountering one cycle, which is used in the testing phase, while the BPM displayed on the watch will take the average of the BPM reading for 5 seconds.
So now I'm going to talk about the additional feature that we have designed for this M5 watch, which is medical reminder. According to our research, we found out that 55% of elderly do not properly take their medication. Hence, we have come up with these solutions. This slide shows the flowchart for medical reminder. So, firstly, 10 storage arrays per day are created and stored in M5 memory. To store the date, time, and remark entered in Telegram, the M5 watch is required to go Telegram bot mode to receive message from the Telegram bot. In other mode, the M5 watch is not respond to the bot message. The data that we have keyed in will then store in the memory. Hence, to start this program, we need to type this /start to set the time for medical reminder at the Telegram. Once the /start is keyed in, it will show this message to you. There are 5 functions included in the bot to manipulate the data, which are add, remove, display, send, and unsend. So for the add function, we can add a component for a specific date. Maximum 10 days is allowed for this function. The user can enter the medicine that he or she wants to consume as well as the time for the reminder. The M5 watch will beep and the remark will be displayed on the screen where a reminder is triggered. So the second function is remove. In here, we can remove a component from a particular day. Furthermore, when /display is entered, it will display the list for each day. So that's all for us. Thank you.